Hello and welcome to part 3 of the video series about the graphical programming software test.con 6 Studio. In this part I will program a user space application with an HMI interface. Therefore I will create a user space application project. After that I will show you how to create a simple HMI design and how to connect the implemented object with the application connectors. On the screen you can see the final status of part 2. In this part we have implemented the application connectors pincette max, pincette min and reset min max in the application, and we uploaded the application into the real-time kernel of the Q.station accordingly. I will now create a user space project. To do so, I will use the command new in the toolbar. Subsequently, the dialog for selecting the template opens. Here I will choose the template standard application HMI and I will name the project My US App. On the screen you will recognize the system context diagram. In the upper section there is the high-level section of the Q.station. Down here, depicted a little bit stronger, you can see the user space kernel, which is also part of the high-level section. In the lower section, depicted a little bit weaker, you can find the real-time kernel of the Q.station. On the configuration level, meaning here in the system context diagram, there is exactly one program block. This program block is in the high-level section because it is also called in this high-level section. In the programming system test.con, only this program block is a programming element. I can also only change the position of this program block on the worksheet. All other visible elements are part of the background image and are only there for documentation purposes. I will now call the worksheet of this program block. You can see the block diagram of the program block now. In this block diagram there already is a macro block on the worksheet which maintains the communication to the start app. I'll talk about that block a little later on. So what do I want to program in the course of this video? I will display the minimum and maximum values of the tweezers on the display of the Q.station. Furthermore, I will display the current measurement value of the tweezers in the trend block, and I will also place a button which can be used to reset the minimum and maximum values. To program an application with an HMI, there are different ways to approach. Personally, I start with designing the entire HMI. To do so, I will start the mask designer either over the menu Tools or the toolbar. In this video, however, I would like to show you another approach, as I think that this approach will be easier to understand for you to start off. For that reason, I will close the mask designer now. So first, I will look for blocks in the block library which can be used to display values on the screen. In the favorites tree, I can find the library display HMI. Here I can find different libraries like standard objects, objects advanced, and parameter blocks. I will select the library standard objects. In here I can find the block numeric value. This block is used to enable a connection to the graphical numeric object. I am placing such a block on my worksheet. Subsequently, the mask designer opens and asks me in which mask I would like to place my object. In this application template, 2 masks have already been prepared. One is the navigation bar, which you can see up here. It is the upper bar to get to the start app. This is a design proposal from us, so every application has such a navigation bar. We wanted to facilitate the navigation inside the application, like for example to get to another application in a relatively easy and standardized way. This page already has one mask, called 101 page 1. I will choose this mask. Here I would like to place a numeric value. I will implement the name of the graphical object here, which is pin_set_max. Now the system will implement an object on this page. Here you can see the object. I can position and parameterize it on this mask just like I wish. I will now parameterize the object. You can call the parameter dialog by double-clicking on the object. I will change the background from black to invisible. Furthermore, I would like to enlarge the digits. To do that, I will select the font from the comprehensive font selection. I am choosing a very big font, XL Bold. Now the display is set according to my specifications. Subsequently, I will adjust the field display format. Under a fixed number of decimal places, I will specify the number of decimal places. Now I can place the according value on the mask. By confirming with OK, I will link this graphical object with the function block in the block diagram. I am zooming into the worksheet. This function block is now linked to the graphical object pin_set_max. This graphical object is on the mask 101 page 1. The upper bar always shows the mask in which the object is implemented. Now I will connect the app connector pin_set_max with the input of this block. That is how I make the connection to the real-time kernel. I will dock an attribute using the command assign variable. Subsequently, the data point management will open again, and here you can see the project variable. We have not yet created a project variable, and that is why the section is still empty. You can see this section GIO or Gantner.io. It is still empty as well because we did not make a connection to the Q.station yet. We cannot see the app connectors yet. With the command import Gantner.ios, I will now scan the Office network. You can see the scan dialog, which is scanning the Office network. The system now finds 3 controllers. The first one is the Q.station, which you can see then right on the webcam. I will select the user kernel. After scanning the Q.station, the section Gantner.ios refreshes. In this case, the section is renamed Q.station IP.dt. The system has found only one real-time kernel because only one real-time kernel provides an interface. That is the real-time kernel, which we have programmed before in part 2 of the video series. In the section App Connectors, you can find 2 variables, pin_set_min and pin_set_max. The variable reset_min_max cannot be found here because 1. The filter of the data type float is active and the reset variable is of the type bit_byte, and 2. The filter for read is active. This filter function is a default setting, as we want to connect the attribute to an input of a function block, which has a data type float. The input switches the filter to read, and the data type of the input is float. And that is why the filter is set to read and float. I will now select the variable pinCetMax. You can see now that the tweezers have been assigned. To fully show the text, I will change the length of the attribute from 50 to 100. Now I will expand the program so the blocks pinCetMin, resetMinMax and the trend block for the current measurement value can be seen on the display. I will zoom out for that and make a copy of this block combination, numeric value and the attribute. As I have made a copy of the block, the copy refers to the same graphical object of the tweezers minimum attribute and also shows that in the designer. I will now create a copy of the object in the designer and implement this copy in the designer. I will name this copy pinCetMin and place the copy below the maximum value. I will confirm this with OK. Now I have to adjust the application connector accordingly and change to the variable pinCetMin. Now I will implement a block to reset the min-max function in the real-time kernel. That is why we will implement a block button in our block diagram. The designer opens and here I will type in the name of the object, reset min-max. I will also implement this graphical object in 101 page 1. Now I will place the block on my page. By double clicking it, I get into the menu. Here I can name the block Reset Min-Max and choose the font M Bold. Here we have the button Reset. Now I have to connect the application connector to the button over the command Assign Variable. I will now get to the App Connector section and select the Reset Min-Max attribute. Next I will implement a trend block. The system asks on which page I would like to implement this trend. I will select 101 page 1 and name it Trend Pinzette. Up here I will find the according graphical object. I will configure this now as following. I do not want a background color. The draw field should also have no color and the time scale as well as the Y scale should be painted white and the lines are also supposed to be white. Now this is my current configuration. I will confirm that with OK and assign this trend block to the IO variable tweezers over the section Q.station IP.dt and not over the application connectors. I can now access the IOs. Here in the third QBlocks module A101 I can find the tweezers. To scale the trend in direction of the Y-axis automatically, I will link the min-max values of the scales of the min-max values. I will use the pin block to be able to access the data of the block attribute. I will implement another pin block for that. Now I will connect the results with the corresponding values. I will now download the program over the command download into the user kernel of the Q.station and select the user kernel by double-clicking on it. Now the program is being uploaded into the kernel. As you can see on the display of the Q.station, the startup is still there. Over the green field, I will get to the user application. I can see the user space application, which we have programmed. When opening and closing the tweezers now, I can see the results on the screen accordingly. Up left, you can see the trend. Over the button Reset Min Max, I can reset the block. Now I can see how the trend is scaling. I can also reset the values again, as you can see. That is the result of our user space program. The user space program itself is only responsible for showing the values on the display. The actual functionality, meaning min-max values, is executed in the real-time kernel. Thank you for your attention, and I hope I will welcome you again in our next videos.